it'll show the time, then it'll ask me to print the right finger. So this is my right middle finger. And then there's a good morning message, as seen. Hello, my name is Naol Ketema, and this is Project 2.7.4, the Random Fingerprint Sensor Alarm Clock. This is the working breadboard prototype, and the way it works is by first setting an alarm, and then when the current time matches the alarm time, the buzzer will go off and sound. The fingerprint sensor will be initialized, and then it will continuously scan to see if there is a match with the selected fingerprint. The fingerprint sensor will continuously scan to see if there is a match with the selected fingerprint, and the selected fingerprint is the one that is to be scanned, and that is going to be displayed on the LCD. Once a match is found, it will print a good morning message on the LCD. And this is the prototype working. There is a number associated with each of my fingers. So my first finger is going to be my right thumb, my fifth finger is my right pinky, my left thumb is the sixth finger, and my left pinky is the 10th. So it goes in that order, and the hand and the exact finger are associated with each of the numbers in this code, as you can see, in this array. And the name of the array is finger labels. So, changing gears, a crucial part of the project is the DS1307 RTC. It is a binary coded decimal clock device that operates with relatively low power, and it utilizes the I2C for the transfer of address and data. For example, we're using pins A4 and A5, and they're connected to the pin A4 being connected to the power and pin A5 being connected to ground rails, but they're not actually having access to power or ground. We're just using it for for I2C communication. So the DS1307 RTC keeps track of the day of the week, the date, the month, the year, the hour, the minutes, and the seconds, and it is manually set. So let's take a look at the LCD and the random finger aspect. So once a random finger is selected, the LCD displays the selected finger, and while the fingerprint is not matched and the alarm is not turned off because it wasn't on, the buzzer will turn on for about 0.9 seconds and then off for 0.9 seconds, and it'll switch between the two states until the alarm is turned off. And the RTC can display the time in 12-hour or 24-hour format, but in this code we're using the 24-hour in this project. For normal function, the temperature needs to be between -40 degrees Celsius and 85 degrees Celsius. That's for the DS1307 RTC to operate properly. And even though it can be a little bit inaccurate, like it can be a few seconds off, using a DS1307 library might help mitigate or fix the inaccuracy in the time. The crystal here is important to keep the precision of the time and a stable clock signal. Moving on, let's take a look at the piezo buzzer. So the piezo buzzer is connected to digital pin 9, as you can see following this yellow wire. It is connected to digital pin 9, and it's connected to ground as well. And connecting it to a digital pin allows the nano to dictate when it is on or off. Although the PCB version of this project does not work, we can still take a look at the parts. So there's the 1x16 female header for the LCD. There's a PJ002A power jack that we can connect to power. There's also a 3001 coin cell battery holder, and that means there would also be a coin cell battery, but it's not on there at the moment. There is a surface mount LED and a surface mount 1K ohm fixed resistor. Additionally, there's a 6-pin chip seat for the DS1307, and we have two 1x15 female headers. And now let's take a look at the cases. So this is the first version of the case, and this is the second version. I hope you took away something from the random fingerprint sensor alarm clock project in terms of the security applications of the fingerprint sensor or anything else. Thank you.